Minerals are identified by several physical properties that they contain, and in your packet that you received for the online class, you will see several pieces of very simple equipment. Number one, a magnet will help you test the magnetic properties of the minerals in your kit. Number two, you will find several pieces that will help you test the hardness of the mineral. The first piece you have with you already, and that's your fingernail. Your fingernail has a hardness of 2.5. If your mineral is softer than your fingernail, then your fingernail will scratch that mineral. The next piece is a penny, preferably a copper penny before the year 1982. If your mineral is softer than 3.5, it will not scratch the penny. Finally, you have a glass plate in your kit, and that glass plate has a hardness of 5.5. If your mineral scratches that plate, it is harder than 5.5. The other two pieces that you see here are streak plates. Minerals have certain colors of powder when streaked across a porcelain plate. This property helps us to identify those minerals. You have a white streak plate or a cream-colored streak plate, and also a dark streak plate that can be used if your mineral does not produce a color on the white plate. So these are the common pieces of equipment that you'll need to complete the mineral identification lab. Let's begin our mineral identification chart by completing an example of a mineral, walking through the different steps of identifying the different physical properties of the mineral, and finally naming that mineral. The first thing we want to do in column number 1 is to identify the color of this mineral. Looking at this mineral, we can see that it appears to be a light gray, or maybe even a light cream color. The streak of a mineral refers to the color that that mineral leaves behind in the powdered form when pulled across a streak plate. Pulling this mineral across the white streak plate, we find that it leaves a white powder behind. Pulling the mineral across the black streak plate confirms that we do indeed have a white powder left behind by this mineral. The luster of any mineral refers to the quality and the intensity of light that is reflected from the surface of that mineral. Picking up our example mineral and moving it around in the light, you'll notice that we have a glassy type reflection. So this particular mineral has a glassy luster. The hardness of a mineral, as we mentioned earlier, is tested by using common items that we may find in everyday life. The first is your fingernail. If you pick up a mineral, your fingernail has a hardness of 2.5. Scratch the mineral with your fingernail to see if your fingernail leaves a scratch. And in this particular mineral, it does. This means that this mineral has a hardness of less than 2.5. Your fingernail is harder than that mineral. If we did not leave a scratch, the second step would be to take a penny and try to scratch the penny with the mineral. If the mineral scratched the penny, then the mineral would be harder than 3.5. Again, if it scratched the penny, we would move on to a glass plate. And if that mineral scratched the glass plate, that means that this mineral would be harder than 5.5. But we know that our fingernail scratched this, so the hardness is less than 2.5. When minerals fracture, they break in one of two ways. Either randomly, and we call that fracture, or they have cleavage. When a mineral has cleavage, it breaks along a preferred plane due to the arrangement of the ions inside of the mineral. Looking at our sample mineral, we will test for cleavage. When a mineral has cleavage, it breaks along a preferred plane, either as one plane of cleavage, two planes of cleavage, three, or four planes of cleavage. Testing our sample mineral, looking at the cleavage, if we lie one side of the mineral in our hand and put the other hand over the top, we can see that this mineral has two flat planes. The mineral is almost like an Oreo cookie, with our hands being the cookie and the mineral being the fluffy inside. This particular mineral has one plane of cleavage. The last two tests we're going to perform on this mineral involve checking for any magnetic properties within the mineral. We do that by picking up our magnet, laying it on top of the mineral, and tipping the mineral to the side. If the magnet sticks, this mineral has magnetic properties. If it falls off, it does not. This mineral has no magnetic properties. The final test that we perform on any mineral is an acid test. We use 10% hydrochloric acid, which you won't have in your kit, and we drop one small drop of acid onto the face of the mineral. If the acid causes the mineral to effervesce or fizz, this indicates that our mineral is calcite. One drop of hydrochloric acid on our sample mineral shows no effervescence, and this tells us that this particular mineral is not calcite. Now that we've performed all of our physical tests on this mineral, let's use our flowchart, our mineral identification flowchart that you have in your packet, to name this mineral. You'll notice that the left side of the flowchart, it asks you, did your mineral have metallic luster? In our case, our sample mineral did not have metallic luster, so we follow the line for no. The next question, does our mineral have cleavage? Yes, it had one directional cleavage. Then it asks, was our hardness greater than 5.5? For our mineral, the hardness was very low at less than 2.5. This brings us to the third major group on our flowchart, and we can begin to use some of the other properties in addition to cleavage and hardness to identify the mineral. Notice that you have choices of fluorite, halite, calcite, gypsum, biotite, muscovite, and talc. We know that our particular mineral had one directional cleavage. The only minerals in this list that have one directional cleavage are gypsum, biotite, muscovite, and talc. We also know that our mineral had a hardness of less than 2.5. The only two minerals within our chart that have that are gypsum and talc. Finally, by examining some of the other properties, we find that our particular mineral does not have a soapy feel, and it is white or clear, indicating that this example mineral is gypsum.